In this video, I will show you how to record the slope-intercept form of a line using units. In math class, you have probably learned how to write down the slope-intercept form given a line. In science class, it's a very similar process. The only difference is in science we put units with our numbers, right? In science, we're actually interpreting data and trying to make better sense of the real world. And so numbers always come with an explanation, and those explanations are units. So this graph is what we're working with today. We've got grams, we've got the mass in grams on the y-axis, and volume in milliliters on the x-axis. And you can see that's very similar to chemistry class, so that we could start with something you've seen before. Now, pardon my tape. I've got some translucent sleeves up here, so I can write on this graph over and over again. But it looks like this graph goes right through the 0, 0 point, right? It goes right through the origin. And so finding slope is actually pretty easy on this. If you have a line that goes through the origin, essentially you can just find a point on the graph, divide y by x, and you have your slope. However, I'd like to show you the method that you want to use if it doesn't go through the origin, because if you try this when there is an intercept that's not 0, it's not going to work. So we need a method that works every single time. The way to find slope, and by the way, if you're going to get slope-intercept form, you're going to need the value of slope. So the way to find slope is to find 2 points on the graph that you can identify both y and x on those points. So I like to find a spot that sort of crosses on the little crosshash of the graph. So there's one. And then this looks like it pretty much crosses right there as well. So I've got a second point. Those 2 points, I can just identify what y and x is at those 2 points, and so they're good points to choose. Now essentially your slope is just going to be this change in y divided by this change in x. I don't know if you can see those lines, maybe if I use a different color. So essentially your slope is this change in y divided by that change in x, right? So there's your changes. That's delta y, that's delta x, okay? However, we're going to need, and if you can't see that very well, I know it's a little hard to see. It's not a big deal, but that's how we're gonna find slope. And if that doesn't make sense, we can write it out like in math class. So let's start with our first point, right? This will be point 1, right? This point here. This point here looks like it's 4, 3. Right? There's 4, 3. And this point up here this is our second point. So this looks like 8, 6. Oops, 8, 6. I'm writing a 4 down for some reason. 8, 6. Okay? So slope essentially just equals the change in y divided by the change in x. And if my point 1, my first point is 4, 3, and my second point is 8, it's a backwards comma, 8, 6. Well, all I need to find then is the change in y divided by the change in x, right? So the change in y for these 2 points is here. Let's do it like this way. Change in y over the change in x. My change in y is just so it goes from 3 to 6. Right? So it goes from 3 to 6. So my change in y is going to be 6. The final, right? Final minus initial. Anytime you have a delta, that's just final minus initial. So if I go from 3 to 6, mathematically, to find that difference, I would say final minus initial, 6 minus 3. And then my y change, it looks like I go from this point, from this point to this point, 4 to 8, right? And so my change in y is going to then be the final 8 minus the initial 4. And when I do the math, that looks like it's 3 over 4. And now one thing to be careful of in science, I'm gonna write slope equals because I'm actually working out the slope right now. So let's put that in. So in science, we don't actually report many fractions in science unless we're talking about a ratio, and we are not talking about that in this. No, we're not. We're not talking about a ratio because we have two different units. And so in science, we want to actually, we like to use decimals because if you actually put the form the number in decimal form, then it speaks to your measuring device. You can have the proper sig figs. We can't do proper sig figs with fractions. So we're going to put this. We're going to say that this is 0.75. Okay. Technically, we might want to have just one unit, but we might want to have only one sig fig. But because we have one sig fig on the axes, however, I'm going to put 0.75 because that would just mess with me to have that as 0.8. I wouldn't like that. So anyway, 0.75. Now the other thing we have to do is we need a unit, right? On every number we need a unit. And so we've got 0.75 what, right? Well, we did y over x, the change in y over the change in x. And so that we should just use the units in y and the units in x, right? So we did grams divided by milliliters. So this is actually 0.75 grams over milliliters. There you go, right? So that is my slope. And now I need to put the whole point of this process was to show you how to write slope-intercept form. And so let's work on that now. Remember that slope-intercept form is essentially y equals m. It's y equals mx plus b. You probably remember that from math class. Mx plus b. And what does all that mean? Well, the y is your y-axis, the m is your slope, the x is your x-axis, and the b is your intercept. In this scenario, since it's plus b, that would be plus 0 because we have 0 intercept. So we can kind of ignore b, which is nice. But let's start with y. What do we do when we want to write a slope-intercept form in a scientific way with units? What do we do on y? Well, it's just going to be y, the y-axis, right? And the y-axis is described, right? This is the difference between this graph and a graph in math class, right? Is that I actually have labels on my axes. And you're just going to, instead of saying y, you're going to use that label on your axes, right? So y is mass. I'm color coding these, right? Mass, and then I might as well I can put my unit, mass in grams, okay? So, equals, so the difference between this and math class is I'm just going to say, hey, you know what? I want to put y, I'm going to say what the y-axis really is on my equation as well. Y equals m, and what is m? M is the slope that we just calculated, right? M is right here, so it's actually a value, so 0.75 grams per milliliter, right? And then x, what is x? X is just the x-axis, right? And I've described it right here. So x is volume in milliliters. I'm going to put it times volume in milliliters. All right, don't get dizzy here. I'm gonna turn the camera a little bit. All right, so now look at this. So y equals mx plus b. The y is just the label for your y-axis. M is the slope you calculated with the units. X is just the label for your x-axis. And if my graph had an intercept that was not equal to 0, then the plus b would be plus whatever the intercept is, and it would have the unit of y because it would be a y-intercept. So it would have the unit of mass because that's on my y-axis. Okay, I hope this video helped. Have a good day.